Hello, we are entering chapter 6 polynomials. I'm going to teach you how to perform the divisions of polynomials. Alright, so how to do long division by using the polynomial for polynomial. So as you learn during your primary school, that when you divide a number by its dividend, so for example you have 71, right? 71 divided by 3, for example, you will have 2, 3, 6, right? This is the way you divide, right? 2 times 3, 6, which 7 minus 6, 7 you minus the 6 here, then you have 1, right? Then you bring the 1, come down again, then 3, then you have a number which is cannot larger than 11, which is a multiple of 3, which is 3, right? 3, 3, you have 9, right? 11, you minus 9, 11, if you minus 9, you have 2, right? 2 is smaller than 3, right? The value is smaller than 3, so we stop here. And we said this one is your baki, right? Your remainder. So 2, how to write? So you know that 71 divided by 3 is the same as 71 divided by 3, right? In fraction. So it's the same as you take the 23 plus with the 2 over with the 3, right? Your remainder divide by this. So then you have 23 2 over 3, right? So if you calculate 3, then our teacher said 3 times 23, you have 69. 69 plus 2, you have 71 over 3, right? So this is a improper fraction, right? Pecahan tak wajar, and you change it become pecahan wajar, right? It's a proper fraction. So it's the same thing also apply here. Before that, I'm going to introduce you about what is the name for this. This one we said it's to be a quotient, right? A quotient. And this one is your divisor. Your divisor. And this is your dividend. Okay? Or in this case, it's your polynomial, right? Polynomial. And this will be your remainder, baki, your remainder. So each of these we rewrite as algebraic form, which is Rx, this is your dx, your divisor is dx, and this is your px, the polynomial, and quotient, qx. So from here we can see clearly that the px divided by the dx, your dx, this is your polynomial, your px divided by the dx, px divided by dx is the same as 23, which is your quotient plus with the remainder, your remainder, which is Rx divided by the dx, right? Your dx. Or we can rewrite this in the form, okay, this is the first form. A second form will be, we multiply everything with dx. We multiply everything with dx, we have px, which is qx dx plus with rx, okay, first form and the second form. Alright, the first form and the second form. Okay, I'm going to show you what is the meanings of this division here by using the knowledge for long division. Alright, just like you do when you apply to number, right? So this is now a polynomial. This is your px. Divide this one by this one. This is your dx. Alright, your divisor. So you're going to apply your knowledge for the division for a number into a algebra, which is a polynomial. So then your divisor is x minus 3. You have x power of 3 plus with 2x power of 2 minus with 10x divided by x minus 3, right? Divided by x minus 3. So you see how I divide? Very simple. You look at it. First, you need an x cube here. You want x cube here so that you can minus and the x cube gone. Alright? So you're going to eliminate the x cube. So how? You're going to multiply the x square into the x here. Because x square and x, you have x cube. X square multiply with x, you have x cube. Right? So that's why you choose x square. So the x square have to be multiplied negative 3 as well. So you will have negative 3 x square. Alright? So means x square. Why are you choosing x square? Because x cube, to get x cube here, you need an x square multiplied with the leading coefficient here so that you get x cube. So x square, x cube, x square and negative 3 x square. Then you have minus, you have to minus. So just like you apply for number, you minus, then you get the next one. So x cube minus x cube, you have 0, right? 0. So 2x square minus minus plus, right? So 2 plus 3x square, you have 5x square, right? 2, negative, negative, positive 3. 2 plus 3, 5x square. So then this one you bring forward negative 10x, right? So now this is your leading coefficient here. So now you're going to eliminate this. So you put 5x square here. You want a 5x square here. So that you can minus and you're getting 0. So what you're going to choose is depend on, if this is x, here should be 5x, right? Because 5x and x, you have 5x to the power of 2, right? 5xx, x square. So 5x. So then this 5x has to multiply with negative 3 as well, which will be 5 multiply negative 3, you have negative 15x, right? Again, you minus. 5x square minus 5x square, you have 0. You have 0. So for this one, you have negative 10. Negative 10. Negative, negative, positive 15. So negative 10 plus negative 10 plus 15, you have 5x, right? Negative 10 plus 15, you have 5x here. So, not finished yet. Why? Because x, this is also power of 1. This is also power of 1. So, the degree for the remainder has to less than the divisor here. So, then now you want 5x. There are nothing you can bring forward now. So, 5x means you need a 5x in order for this to get away, right? You need to eliminate 5x. So then you have to, x here have to be 5, right? Because 5 and x, you have 5x. But don't forget, 5 and negative 3, you have negative 15, right? Negative 15. 5 and negative 3, you have negative 15. So 5x minus 5x, 0. Negative, negative, positive 15. Now 15 is x to the power of 0, which is lesser than the power 1 here. So then you stop. This is your remainder. Your remainder. Okay? Your remainder. Remember the name here, remainder. And this is your divisor, your dx. This is your polynomial. And this will be your quotient. Right? And you have everything here. You're going to rewrite this whole thing in a proper way to present your answer. Means that your x cube, therefore, your x cube plus with 2x to the power of 2, the polynomial, divide by what? X minus 3. This is called the improper fraction. Improper fraction. Improper fraction. Because the degree higher than the degree below. Right? You see the degree? 3. This is the 1. So I'm going to do long division to make it become proper. So very simple. It will be a quotient, qx. Your quotient qx, which will be x squared plus with 5x plus 5 add plus with remainder over the divisor. Remainder over the divisor. So the remainder is 15. The remainder is 15. And the divisor is x minus 3. Right? After you do long division, after you have division, then for the improper fraction, you are getting a proper fraction, which is a quadratic add up with the remainder. Alright? So this is the first form. This is the first form. So you can write your answer in this form. So this form, very simple, is px, which the px here, right? Therefore, your px x cubed plus 2x squared minus 10x 10x is equals to the qx, your qx x squared plus 5x plus 5 qx and dx. Your dx is x minus 3 plus with your remainder. Your remainder is 15. So means that this one is equivalent to this form here. Alright, if you expand it, you will get back the same thing here. So this is the use of long division, right? So hope you understand. And we see for the we go for the next example. Hi, let's look at this example. Divide x power 4 plus x cubed plus 4 by x squared minus 3. Okay, divide means you need to perform long division, because you see that this is a degree 4 and this is degree 2, right? So perform long division of this polynomial. So very simple, the same thing. So you're going to put x4 x cubed. But this one special is because suppose a polynomial of degree, polynomial, it should be followed at ax power 4, sorry, px, if they have power 4, it should be have bx cubed, it should be have cx squared dx plus c. It's a chain, right? Chain means from x power 0, x power 1, x power 2, x power 3, x power 4, right? So to avoid mistake, so it's better, I suggest you to put a 0, because this is a constant, right? Meaning there is a gap here. Means that you see x power 4, x power 3, then this two term is 0, right? Then become the constant 4, right? So I'm going to add a 0x squared here, 0x squared here, to assist in my division. So 0x plus with 4, right? It's the same thing. So x power 4, x power 3, I just add up the 0x squared, 0x plus 4 to make it nicer. And it will help you in your long division. So x squared minus 3 is okay. You just write there x squared minus 3, right? So we can start the long division now here. So you want to eliminate the x power 4, right? You want to eliminate the x power 4 here. So you need x power 4. So x power 2 here, right? What make up x power 4? What you need here is x power 2, because x power 2 and x power 2, you have x power 4, right? So then together, x power 2 multiply with negative 3, you have negative 3x squared here. I'm not going to put below the x cubed to avoid confuse. So x squared, and now it's x squared, negative 3, you get negative 3x squared together with the x squared, the 0x squared here. So this is why I'm adding a 0 here. So divide. So x4 minus x4, you have 0, right? You have 0 here. So x cubed minus 0, you will still have x cubed, right? You bring this one forward. And this one 0, negative, negative, positive 3x power 2, right? 3x power 2. And this one, you just bring it down. Bring it down. After you minus, then this one, the remaining one, you bring it down. So now go for the second one. Then you need to eliminate this leading coefficient here. So you go and you need the x cubed here, so that you minus, you're getting 0, right? So what is it? You look at here, x squared. So you need x. You need x here, because x and x squared, you have x cubed, right? X multiplied with x squared, you have x cubed. X and negative 3, you have negative 3x. So I put under the x here, negative 3x here, together with 0x, because this is x the same power, right? X power 1. So then I put bracket again, I put minus, divide, right? So x cubed minus x cubed, gone, right? Then this one bring forward, and you have 3x to the power of 2, right? 3x to the power of 2, 0 minus minus, you have positive 3x, right? Positive 3x. Then 4, bring down, you have 3x squared plus 3x plus 4, right? So plus 3x, 4. So x squared is still, the power, the degree is still the same, right? So you have to be less, the remainder have to be less, the degree have to be lesser than x power of 2. So then I need to eliminate the 3x squared, the 3x squared here. So how? I need a 3 here, because 3 and x squared, I get 3x squared. 3 and x squared, I get 3x squared. 3 and negative 3, you have negative 9. Negative 9. So again, subtract 3x squared minus 3x squared, you have 0, right? 0. 3x minus nothing, you get back the 3x. 4 minus minus, you have 13, right? You have 13. So this will be your remainder. Why? Because this is power 1, this is power of 2, right? So you cannot continue the division. They are no longer valid. So you don't continue the division. So this will be your remainder, your baki. So this will be your quotient, your qx. And this will be your, this one of course you know, this is your divisor, this is your polynomial, and this is your remainder. So you know that you can write in pq, px over with dx equals to qx plus with remainder divided by divisor here. Alright, divisor here. So, or in another form, this is number 1, number 2, another form will be px is multiply everything with dx lah. It's a qx dx plus with rx. Alright, so for the first one, you write in the form of px. Px, you know, this is your px, your x power 4 plus with x power 3 plus 4 divided by x squared minus 3, which is the same as qx, your qx, quotient, x squared plus x plus 3 plus with remainder, remainder is 3x plus 13 over with your divisor, which is x squared minus 3. This is an improper fraction, improper rational function. This is a proper function here. Okay, proper rational function. So or you can write this as a multiple of qx. Your qx will be x squared plus x plus 3, and your dx will be x squared minus 3 plus with your remainder 3x plus 13, right? So px is your this one, right? So if you multiply, you will get back the x power 4 plus x cubed plus 4. So this is the way you present your answer, right, after you do long division. So that's all. I will give you more example for long division in the next video.